Hello, everyone. Welcome. Thank you for being here. It's great to see so many people here early. I hope you're excited to be here. We're going to talk about a lot of fun stuff. I'm going to start right on time because I got a lot to get through, a lot of cool things that I want to show you. My name is Daniel Roth. I'm a program manager on the ASP.NET team. And today we're going to build some OData services. And we're going to build them using ASP.NET Web API. Should be fun, should be exciting. I hope you're excited. Are you guys excited? OData? Oh yeah, OData. Okay, so let's talk about OData. Now I'm assuming that you're here because you've already heard a little bit about OData. You know at least a little bit about it. But if you don't, this is your one-slide tutorial. OData is an open web protocol for querying and manipulating data. It's an open web protocol for querying and manipulating data. It's a web protocol, first of all. That means it's over HTTP. It's meant to be consumed by things like browsers, by things that are web-facing, like mobile devices, phones, tablets. That's all fine. It is a web protocol, and it is open, which means that the spec is published. You can read it. It's based on open standards like JSON, XML, Atom. And it is being standardized. It is currently in the OASIS standards org. V4 of OData is actually out for public review right now. So you can look at the V4 documents, see what's new, see what's in there, and find out about it. There's some nice industry momentum around the spec. And it's a protocol specifically for querying and manipulating data. So if you have some data, like sitting in some database, and you want to make it available somehow to the web, to things that are operating on the web, so that you can query over it and manipulate it, OData is probably going to be a good fit for you. It's not a good fit for everything. If you're doing very action-oriented patterns or connection-oriented patterns, or you have more complicated messaging patterns, it may not be the right fit for some of those cases. But if you have something that fits in the model, it works great. And I think for a wide variety of services that people are building on the web, OData solves a lot of the common problems that you end up needing to solve anyway. So that's what OData is. ASP.NET Web API, again, I'm assuming you're here because you know at least a little bit about what ASP.NET Web API is. I'm not going to do a general overview of the core ASP.NET Web API. But if you haven't heard of it before, here's your one-page, one-slide tutorial. ASP.NET Web API is a relatively new framework for creating HTTP services. It is not a framework for creating SOAP services. So that in that sense, it's not a replacement for WCF by any means. It wasn't actually even designed as a framework for creating OData services. It was designed for HTTP. You want to expose some data, some logic over HTTP, and it gives you a beautiful first-class programming model for dealing with HTTP. So if you care about things like status codes, honoring the verbs of HTTP, using HTTP as it was intended as an application-level protocol, ASP.NET Web API is for you. And it specifically was intended for services where your goal is reach. You want to hit as many clients as you possibly can. Browsers, phones, tablets, set-top boxes. One of the things that almost all these devices have in common is they actually all have an HTTP stack. They can send and receive HTTP requests. Not all of them can send and receive SOAP requests, but they can do HTTP. So building your logic as HTTP services is a great idea if you're trying to plan for that world where you might want to take that service, that logic, and make it available on a variety of clients. That's what ASP.NET Web API is for. Because it was an HTTP framework, one of the things that one of the design points was that, well, anything can go in an HTTP request. Anything can go in a response. Any media type that you can dream up, you can put in the body of an HTTP request a response. It could be text. It could be binary. It could be images. It could be PDFs. Whatever format you want to create, it can go in those messages. OData defines a format and protocol, and it is just another interesting format that we think we want to support. We want to have a great OData story for ASP.NET Web API. So I think hopefully you can see how these two things they can go together pretty well. It's like they almost like they were made for each other. So one way to think about about OData and Web API is that there are actually a bunch of problems that it's pretty easy to get started with a Web API framework, whether it's ASP.NET Web API or pick your third-party Web API framework of choice. It's pretty easy to get to a point where you can push around some JSON, make some requests, receive some responses. But at some point, you start to hit these other kinds of problems, and you have to ask yourself, how should I do these things? Like data often has relationships. You have to-do lists and to-dos. A to-do list has to-dos. And sometimes you may just want the to-do lists, and you don't actually need the to-dos yet, because you're just going to print some summaries of them. But then later you might want to go get the to-dos. Standard serializer-based approach to services will greedily grab everything and serialize it to the wire. But maybe you don't want that. Maybe you want to preserve this notion of, I just want part of the data, and I want links to the rest of it. I need a way to navigate those links. I need a way to manipulate those links, change the relationships. How do you do that? You could invent your own solution, or you could use an existing open protocol. Often you have large amounts of data, like a collection. Maybe I'm a very busy guy, and I've got 10,000 to-dos. And I may want to query over that data set. I may want to order it. I may just want the first 10. I may want to filter into those to-dos. Maybe I want some data about a to-do, but not all of it. Like, just give me these 3 properties of this to-do item. Maybe I want to page through the to-dos, so I don't have to get them all at once. How do you do that? You could roll your own solution, or you could use an existing open protocol. Actions. Often data has associated things that you can then do on that data. Like, imagine you have a resource, an HP resource which represents a movie, and it's a movie rental store. And you can check out that movie if it hasn't been checked out yet. But if it's already been checked out, then that action is no longer available. How do I discover those actions? Ideally, there'd be some data in the payload that tells me, you can do these things, and also here's how you do them. Here's some metadata that tells you when you want to perform that action, here's how you do it. Great. How can I set those type of patterns up? With traditional web APIs, there's no metadata. There's you could invent your own solution again, or you could use an open protocol. Batching. You want to send a whole bunch of requests all together so you can save bandwidth, save battery. How do you do that? You can invent your own or use an existing protocol. And you'd ideally like to solve all of these problems in a way that that people who want to consume your web APIs can already know how to do it. Ideally, they don't have to relearn a new way of doing query, of doing paging, of doing batching with each new web API that they encounter. Ideally, there's some uniformity that they can take advantage of so that your service is easier to consume. More clients will have an easier time consuming your service. You get better reach. OData provides a standard solution for all of these very common web API patterns and problems. Another way to think about web API and OData is that today with web APIs, at least with ASP.NET Web API, there is no data model provided for you. Web API is data model-less. OData provides you a data model, and that's a very powerful concept. With Web API, normally you just have an object, and you have a formatter that knows how to handle a media type, and the data can be formatted, and you can deserialize it, and it's opaque to the runtime. With OData, there is a data model. It uses the entity data model, and that data model has structure. There's entity sets, there's entity types, and those entity types have properties, and some of those properties can be complex. They can be complex types. These entities can have actions. You can have functions. And with the data model, a framework can do more for you. It can provide metadata about what your service exposes. It can set up routes it can set up the URI space for your service for you instead of you having to do it manually. When you want to generate a link to a part of your service, Because you have a data model, it's easier for the framework to generate that link for you. It's easier to query because you have a data model to reference when you're executing queries. All these things become easier when you have a data model. But I want to be clear that this doesn't mean that you take your data model from your data tier and then expose it directly as a service. That's by no means a requirement. The data model for your service is completely independent. There is an easy way, if you happen to be built on SQL and like Entity Framework, for example, to take that existing Entity Framework EDM model and expose it if you'd like to, and you can tweak it and say, but I want to hide these things. That's one pattern. But if you have like a completely different data source, like it's just another set of web APIs, or it's files on disk, or a fast typing monkey, that's fine as long as you have some way of mapping it to whatever entity data model that you want to define for your service. That works, and that's totally cool. And the good thing about integrating with OData is that we can take advantage of the existing ecosystem of clients that already exist that know how to consume OData services, like WCF Data Services Client. If you happen to be writing .NET code, if you're writing in JavaScript, you can use Data.js. There's a great new third-party library called Breeze.js. If you're a business analyst type, you can use Excel, and so on and so forth. So what is ASP.NET Web API OData? It is a set of components that we've added to the framework for implementing OData services. And I want to really emphasize that word, components. It's not an all or nothing deal. Like I think a lot of times people, there's been some reaction to OData that almost brings too much to the table. You get too much stuff. With ASP.NET Web API OData, one of the design goals is that you can bring as much OData, support as much OData as you want. We give you the pieces, and we give you easy ways to put them together. But if you only want part, that's fine. Maybe you like query, and you're like, I need some way to query my data. I have a format. I'm not going to change it, but let me use this query parsing logic and query execution logic. Maybe you like the format. I like that if I use this particular format, I can import it into Excel really easily. But that query stuff, I don't want to expose my database to all sorts of crazy queries, so I'm going to lock that down, and I'm actually going to support very few queries. That's totally fine. You can use as much as you want. We give you pieces like model builders for setting up your entity data model. We give you formatters for dealing with all the different OData formats, JSON, XML, Atom. We give you parsers, parser for the path of the URI that understands what this URI path is referring to in your model. We give you a parser for the query so that you can have a representation of the actual query that the client is trying to execute. We give you a piece that you can take that parsed query and then turn it into a link expression that you can apply to an iQueryable. But all these things are pieces that you can use independently and choose how much you want to do. The whole framework is built on OData Lib. OData Lib is a Microsoft library for working with OData. It's a fairly low-level library. It's kind of like at the XML infoset layer for OData, but it's the same underpinnings that's used by WCF Data Services. And so it's we're built on an industry-strength OData platform. Our whole framework is open source. It's part of the ASP.NET WebStack Codeplex project. It's the same Codeplex project where the code for MVC lives, Web API lives, Web Pages lives. It's all there. It's open source. And we do accept contributions. So if there's a OData feature that you're just dying to have, we don't have it yet, and you really need this OData feature, feel free to contact us to contribute some code. We've done that in the past. We're still doing it, and we're happy to work with you. We have already shipped a version of ASP.NET Web API OData with a limited set of OData features. It went out with Visual Studio 2012 Update 2. So if you've got that, you've already got Web API OData on your box. It's also available on NuGet as standalone NuGet packages, so you can pull it into any project that you like. OK, enough talk. Let's build an OData service. So there's 3 simple steps to build an OData service with Web API. Step 1 is you need to create your EDM. And the way you create your EDM is using one of our EDM, our model builders. We give you a convention-based one out of the box that can look at your types and infer an entity data model from it. Step 2 is you need to set up your route. So we need some way to know how you want a request to route to your OData service. And you do that using ASP.NET routing. The nice thing about OData is you just need basically one route. We just need to know the prefix for your service, and the whole rest of the URI space we can just figure out for you. You don't have to manually set up routes for all the interesting relationships and resources that are in your model. So you give us a prefix and a model. In step 3, you then need to actually go and implement your entity sets, the top-level concepts in your service. So let's do it. Our first OData service built using ASP.NET Web API. OK, step 1, we need a model. So to build a model, I started code first. This model is a set of to-do lists. So here's my to-do list model. Can you guys see that? No, you need it bigger. That's why we have this lovely little button. How about that? Yeah, OK, great. So to-do list model is pretty simple. It has an ID, a required title, and then a list of to-dos. The to-do, equally simple. That's not, apparently doesn't stay big. To-do has an ID, has a title, an is done flag, and then the foreign key relationship with its parent to-do list. OK, so this is using Entity Framework code first conventions. If you want to start model first, that's fine. You get the types. You do need types in Web API OData. We don't currently have a typeless story. Those types don't have to be your Entity Framework types directly. You can use whatever types you want and then map them. But we do need to have some type currently. We're working on an untyped model, but it's not out yet. All right, so that's my types. Now I need to build an actual EDM model from that, and I'm going to do that using a convention-based model builder. So down here I have this little helper method, a little static helper method, create EDM model, and I'm using OData convention model builder, which should look, if you're familiar with Entity Framework, it should look very similar to the EF model builders, but it's a separate model. And then I just specify my 2 entity sets. I have 2 top-level concepts, to-dos and to-do lists, and I just point them at the type for the entity type essentially for those entity sets. And then I just say get EDM model. And that convention model builder is then going to look through the type and figure out what the EDM model for those guys should be. If you then want to tweak it, you can go in and ignore properties and such. Or if you want to have complete control, you can just start from scratch, start with some types, start with the model builder, and manually map properties to entity types and so forth. You have complete control of that model here. All right, so I've got a model. That was step 1. Step 2, I need a route. This file is my standard Web API config file. This is what sets up all the configuration for my Web APIs. And OData services in Web API are just another Web API. So I need a route. I'm going to use this map OData route extension method. The route needs a name. That's just naming the route so that it can be referenced in other parts of the system. But then the next parameter is a prefix. This is the prefix to my OData service. In the base part of the URI, and then you give it the model, and it figures out everything else. And what's really happening here under the covers is that this route is adding a route constraint. And when a request comes in, and you have a URI, the routing system hands the URI to this particular route to decide if it's going to trigger or not. That route constraint looks at the URI, it parses the path based off of the EDM model that you gave the route, and it figures out what each segment in that path means, and it tries to figure out what's the entity set for the request. And if the request actually refers to an entity set, it says, yep, this is for my OData service. If it doesn't actually map to one of your entity sets, it says, nope, not for my OData service. And it lets the request continue on. So you can happily have OData services and normal vanilla web APIs sitting side by side, and that's totally cool. All right. And then third, we need to now implement that entity set. Now we've triggered the route, we've got a request, we need to actually get that request to some code that's going to run to actually process that request. And you do that by implementing Web API controllers, just like you would any other Web API. The actions for your Web API control, I need to make this bigger again. The actions for your OData services are a little bit have more semantics than a normal Web API. With Web APIs, the semantic is that you get a GET request, you go execute the GET action. You get a POST request, you go execute the POST action. With OData, there's some more. You can get the entity set, you can get items in the entity set, but you can also get and modify links. There's patch semantics. You can get navigation properties. Those are relationships between your entity and other entities, to-do list ones. To-do list 1 to-dos. Give me all the to-dos for to-do list 1. You need some way to have an action that can handle that kind of request. So there's a few more semantics. So the conventions for an OData controller are a little bit more involved. Fortunately, we provide this entity set controller base type that implements those conventions for you. And instead, you can just override helper methods to provide your logic. So here, for example, is get. This actually is just a normal web API action. There's no parent action that this is plugging into. And it's just returning the to-do list directly. This one is plugging in. This is saying I want to get an individual entity by its key. And the actual action is provided by any set controller, but it calls this helper method. Similar thing for like updates and deletes. You can just implement the create entity method, and that will plug into the post action on the parent entity set controller. So if we just F12 on this guy and look at the methods on the base type, you'll notice that you see normal web API looking actions like delete. Where's post? Post is down here. Put. Those are just calling into those helper methods. So this helps you get going so you get the right patterns implemented so that the request will actually land on an action that can handle it. All right? So that's how you implement your entity sets. Let's run it and see what we got. So I implemented a simple web app client for this OData service. This is a single-page app style application. What that means is it's just pulling down some HTML, and then it's using jQuery to go to the OData service and pull down data and manipulate the data and query the data. And then it's using knockout as a way to bind that data to the UI elements. Just implementation detail of the UI. But OK, here's my to-do list. It's pulling down the set of to-do lists and populating this drop-down. And then here are the to-dos for the selected to-do list. OK, now let's do F12 here and look at the network and see what's actually going on. I'm going to Control F5 that page again just to see what actually happened on the page load. And there's a bunch of stuff here at the bottom for getting all these, CSS and JavaScript. But down here you'll see there's a web API call. It's a GET request to OData/to-dos. And that's asking for, please give me all of the, sorry, not OData/to-dos, OData/to-do lists. Please give me all the to-do lists so I can populate the dropdown. If we look at the response, there's the to-do lists. Now, these to-do lists, the data is down here at the end. Like there's the title. Whoa, sorry. There's the titles, and there's their IDs. And then there's these additional pieces of metadata that are coming with the response payload. Now, that's deliberate. When I coded this, I issued a request that specifically asked for that full metadata. If I look at the request headers, you'll see there's this accept header that was set. And that was set in code. And it asks for JSON. It says, when you respond to this request, please give me JSON. But I really want the full metadata version of the JSON. Now, why did I do that? Well, if you look at the response, one of the nice things about that metadata is it gives me links to navigation properties, to relationships for each of these to-do lists. Like here, this to-dos at OData.navigation URL, blah, 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 blah. That is a property that's telling me, by the way, this entity has some to-dos and they're over there. And then in the client app, I can use that URI to go get them, which is pretty convenient. So that's that linking concept, that relationship concept just implemented for you. I didn't have to really add any code to make that happen. OData just does it for you. It can produce those links for you out of the box, which is pretty sweet. All right, just so you can see the code for what it took to actually send that request. If we go into the JavaScript, make it big. Where's the get all the to-do list is down here at the bottom. So here's $Ajax, the to-do list URL. It's a get request. It expects JSON, and by the way, it expects this particular variety of JSON. So that was a deliberate request. If we look at the next request, though, this to-do list 8/to-dos. So to-do list 8 is the selected to-do list, and then it goes back and gets the to-dos for that to-do list. If you look at this request, the response is much cleaner. This is the default JSON formatting for OData. Like there's very little metadata in this thing. This is what's called the minimum metadata payload. There's actually a third option where you can say no metadata. I don't want any metadata at all. But this version is basically saying, I know how to calculate all the links that I care about, so don't bother putting them in the payload. This is more work for the client. The client then has to, if I wanted to know, what are a relationship for this particular entity, I'd have to figure that out myself. But you can do it based off of the published $metadata document. Okay, so here's the to-dos. Let's see, I've got to take a shower. That's one of my to-dos. Check. It's done, by the way. So no worries there. All right. So that's get. Speaking of metadata, while I'm here, why don't I just go ahead and show that we do support publishing metadata, and in IE, it's going to nicely open it up in Notepad. So there's the service doc. If I go to, oops, can I type? Oh no. OData $metadata. There's the published serialization of the entity data model for my service. I can see the structure of the entity types. There's the to-do item right there. There's the to-do list. Here are the entity sets, to-dos and to-do lists and what type they are. Here's data about the relationships between those guys and so forth. Okay? Let's go back. We did get. Let's do post. Let's create a new to-do list. And I want to capture this again. So let's do not important to-dos. All right, there's a post. Okay, so here's a post request. Interesting thing here is, let's look at the body. This is just the title, not important, that's cool. But if I look at the response headers for that post request, you'll notice a couple interesting things. One is that I'm getting the right status code. Post means create a new resource. And the right way to respond to a client that requested a new resource and it succeeded is to say 201, created. And that's being done for me. I also get this location header. Where is it? There it is. The location header is the HTTP standard way of saying, I created your resource, and it's there. If you want to go get it, that's where you go get it from. And that's just got created for me. And that happened because I derived from that entity set controller. The base post implementation does all those things for me. It also handles handling the prefer header. Like if the client wants to say, I prefer to have content in the response, or I prefer not to get anything back in the response, you can do that because it's implemented in that base entity set controller. All right, so that's post. Let's add some to-dos like shoes. Okay, so we got a new to-do, and that was just a post to the to-dos entity set. Cool. What about update? So when I click on this checkbox and say done, it gets saved to the server, and that's done here with a put request. If I look at the request body, this is basically the entire serialized to-do item, right? It's not just the fact that it was checked. It says the title is tie my shoes. That didn't actually change, but it serialized it anyway. Is done is now true, and the ID of the to-do list. The semantics of put basically say replace the entity with this new one. Here's a completely new thing. Throw the old one away. This is the new one. That works. That seems a little bit excessive. Ideally, I would just be able to say, please update the entity with just this one change, just this property. Well, it turns out there is a semantic in HTTP, actually, that OData leverages called patch, where you can say, I don't want to completely stomp on the entity. I just want to change a piece of it. Here's the things that I want to change. So let's see if we can actually update this application to do that. So I'm going to go back to the code. And here is the logic right now where, when the to-do gets updated, it currently issues a put request. But I've also got some other alternative implementations that instead of issuing a put request, it can issue a patch request. And the amount of data that it's sending is just the thing that changed. Whereas before with the put request, the amount of data is the whole shebang, the whole thing. So when the title changes, let's just update the title. Let's not update the whole to-do. And when the is done changes, let's just update, again, the update is done, not update title. That would be weird. OK, let me refresh. OK, let's look at the network again. If I check, this actually wasn't done. I forgot to take a shower this morning. Now the request is being issued as a patch. If I look at the request body, oh, yes, I forgot. IE does not like to show me patch requests. So we go to a slightly different browser in order to do that. All right. Here's a lovely alternative browser. There's lots, there's open web. All right, take a shower. I did actually take a shower. There's my patch request. And if we look at the request payload, just is done is true. Nothing else got sent. So that's patch semantics. But look at the implementation on the server of what that thing looks like. Here's my to-dos controller. And you'll notice that the to-dos controller actually implements the patch entity little method helper thing. And it takes this nice type, this delta of to-do item. And what delta does is it keeps track of just the things that were changed on the wire, just the properties that came in on the wire. And then you can just take that delta, which is here it's called patch, and then patch an instance with just the things that changed. So we'll go into that entity and just set just the properties that changed. So that's how you can get patch semantics. Now, you also notice that on the to-do list controller, I didn't bother to implement patch. It's not even there. That's, again, that idea that you can bring as much OData as you want. Like, I could have just implemented a few methods, and that's fine. Leave the rest of them as, 400 bad requests or whatever to the client. You can implement as much OData as you need and as you want. OK? Great. Let's also look at, that was quick, post, delete. Let's look at clients. So that was a JavaScript client. We can also do a .NET-based client. For .NET-based clients, we use WCF Data Services client library. We don't ship another client library for Web API OData. Like, we don't need one. We have an existing one. You can just use it. And the way you can generate a client, you can, if I stop debugging, you just add service reference. So I have a little console application. This could be a Windows Store app. This could be a Windows Phone app. Any of the .NET flavors is fine. Add service reference. You type in the address of your OData service, which I believe is that. Go, add service reference, pulls down the $metadata. It figures out what entity sets are there, what types are in them, and so forth. You generate the reference. I've already done that, so I'm not going to do that. And then you can write code like this. Context equals, that's my service reference container. You give it the address of the service, and then you can say for each list, in context of to-do list, write down the list, load the to-dos, because you have to explicitly tell it to go and get to navigate the navigation property, print all the to-dos, and whether or not they're done. And this is all strongly typed, and it was just code that was generated for me. If I debug, voila, same data, really important stuff, nice to have, not important, time I choose, done. Okay? So that's one client. That's a .NET client. You can also, Excel. Excel has a Power Pivot plugin. You can't do an OData talk without doing the Power Pivot demo. It's just obligatory. You've all seen, maybe a bunch of you probably have seen it before, but it's still fun. So here's Power Pivot that I just enabled in Excel 2013. I can click Manage, and then Get External Data. It has integration directly with OData services, data services. So from an OData data feed, let's see, I think my URL is actually still here. There it is. Next. Boom, there's my entity sets. Yes, I'd like it all. It's imported. And now I have my to-do lists, really important stuff, not important stuff, and my to-dos, all nicely imported into Excel. And I could do pivot tables and all that business analyst stuff that I won't bore you with. All right, well, that's cool. So there's 3 clients that I was able to leverage solely from the fact that I exposed an OData service. All right. I figured I'd talk a little bit about what's happening under the covers so you can understand what all the components in play are so you can then leverage them to their full potential. When an OData request comes in, the request has a URI. And that URI first gets parsed by a path parser. We have a default OData path parser, path handler that can look through the path segments of the URI and understand what they mean based off of your entity data model. And its job is to determine what the entity set is so that we can select the right controller to handle that request. And the convention that we use is that we look for a controller that is the entity set name plus controller. And that controller actually doesn't have to be an entity set controller even. It could be the entity set controller derives from a base class called OData controller, and that one just derives from API controller. If you want to just do vanilla API controller and handle everything by hand, you can. The OData controller will add in the formatters and the action selection logic, our action selection convention. So it's convenient to start there. The entity set controller adds in the base implementations of the action selection convention. So it's nice to use those, but you don't have to. They're just there to help. They're components. The convention of using the entity set to find the controller is configurable. We have all the conventions used in our OData implementation are represented by these OData routing conventions. And we have one that maps entity set to controller, but if you want to create a new one that does it differently, you're more than welcome to. You can create custom conventions for both how the controller is selected and also how which action gets selected to handle the request. We do provide a custom action selector. The action selector's job is, given the request and given the controller, is to pick the method. Which method should I call? And we use a specific set of conventions in order to do that. You'll get requests get mapped to the get function, get by ID gets mapped to a get with a key, and so forth. I'll talk about them in detail in just a second. But again, they're just a configurable set of conventions. You can add new ones. You can throw away ours and add your own. It's very customizable. But once the action is selected, the method gets invoked, the method returns, and the data then gets formatted using the OData formatters that we provide. Here's the default set of action conventions that we provide. I'll just go through them pretty fast. You can get an entity set. That's just a get action. You can post a new entity to an entity set. That's a post action that takes the entity in the body. You can get individual entities. You can update entities with get and put actions. You can patch them. You can delete them. You can also manipulate the links using the create link pattern. You can delete links. You can get navigation properties, and that one's a little bit more interesting. The convention there, the third from the bottom, is you write an action that's get and then the name of the navigation property. So like get to-dos was the method on the to-do list controller that handled getting the to-dos for a given to-do list instance. And it took the ID of the to-do list instance. There's also a convention around actions, OData actions. We'll talk about those in a bit. But actions are basically custom service operations. You can just write any old method and then map them into your entity data model using the model builder. And then lastly, there's sort of a catch-all. There's a handle unmapped request convention that if we don't find an action method to handle the request, we call this handle unmapped request method. And then you can do whatever you want in that guy. The good news is you don't really have to remember all these conventions. Like I said, Entity Set Controller implements almost all of them, and you can just derive and override. The two that you still should keep in mind is when you want to deal with navigation properties, you do get the navigation property and the key of the entity that you're navigating from. And for actions, it's just a method. Okay? Great. So that's entities and navigation. How are we doing? Okay. Querying and paging. This is another really common pattern. You got a lot of data and you want to query over it. OData provides a standard protocol and syntax for representing queries. Now, you could do this yourself. You could write Web API actions that take custom query parameters, and then you could have very focused queries just for your particular scenario, and that works. The downside of doing that is it's specific to your Web API. It's proprietary. You're also potentially being a little bit too restricted. Like you may not be giving clients the level of flexibility that they actually want. You could open it up a little bit more. It'll be a little bit more generic and enable more scenarios. But at the same time, you still want to be able to scope, so you're not allowing like crazy queries that may take a long time to execute and so forth. OData, particularly Web API with OData, lets you do that. You can query against any data source. It doesn't actually have to have an iQueryable implementation, but if you do have one, like if you're using EF, that's great. We know how to take the OData query, translate it into a link expression, and then apply it to the iQueryable. And then it will actually run all the way down to the database layer. That's cool. But if you don't have an iQueryable, you can just take the parsed query and map it to whatever query mechanism you happen to have. Like maybe you have some back-end Web APIs that you're calling and you're mapping it to Web API calls. Maybe you have a repository pattern and you're mapping it to particular methods on your repository. That's totally possible. You don't need to have an iQueryable. You have complete control over how the query actually gets executed. And well, just to reiterate, you can support as much query semantics as you want. It's not like you turn it on and suddenly you have this huge query space that you've enabled. You can go in and do what we call query validation, where you say, I only want to allow, I want to allow sorting, but I only want to allow sorting on this property. I do want to allow filtering, but I only want to allow these patterns of filters. In fact, or maybe you don't want to allow filtering at all. You can just throw away filtering. Those type of validation statements you can implement, and then those queries would just be rejected. They just wouldn't run. That's how you can trim the query space to just the scenarios that you honestly really care about. All right, so let's look at some query. Okay, this is a different application. This one is managing a list of movies that I wanted to query over. I'm just going to go ahead and run it. All right. Run the query just so you can see what the app does. Here I'm getting a list of 10 movies, and you'll notice I have these nice big arrows so that I can page through the data. Now, how is that actually happening? Well, if I F12 so we can see what's happening on the wire. Let's run that. Oh, man, let's actually start capturing this time. Okay. Let me run the query. Okay, so here's the get request to the movies, and currently there's no query on this thing, so I just get all the movies. But if I look at the response body, you'll notice that I get 10 items in the response, and at the bottom there's this little piece of OData metadata, hope you can see it, which says OData.nextLength is this link. And what that link is saying is that I've given you 10, but there's 10 more. If you want them, here's how you can go get them. And that's something that's defined in the OData protocol that you can just leverage. How did I turn that on? How did I actually get that feature? If we go look at the implementation of my movies controller, I have a movies entity set. Here's the get action for getting all the movies. And you'll notice it has this queryable attribute on it. That queryable attribute is actually just a Web API filter. It's a concept in Web API. And what it does is it enables a path of parsing the query, turning into a link expression, and applying it to whatever iQueryable got returned from the action. That's what it does. And it has this parameter here that says, I'd like to only allow a page size of X, in this case 10. And when you do that, it'll automatically throttle requests from the client, and it will automatically include a next page link. All right? So that's pretty cool. Adding the queryable attribute also enables me to use the OData query syntax. So if I go back to this little text box here, it allows me to modify the query being used. Like I can say I only want the top 3. There's the top 3. I can say I'd like let's do the top 6, just so you can remember the top 6. So Howard's End, Scent of a Woman, Name of the Father, the last 3 there. Let's say I want to skip the first 3 and get the next 3. So there's that 3. So there's top and skip. You can order things. So order by, I don't know, rating. So now it's order by rating. You can even chain ordering and say I want to order by rating and popularity. Okay, that doesn't look very interesting. Let's do a different one that actually has a little bit more differentiation. Let's order by genre and then release year. Okay, so now order by the genre and also by the release year. So that's pretty cool. So that's top or take, skip, ordering, filtering. I can also say, I'm sorry, I haven't done filtering yet. Let me do filter now. I want to filter the genre to be just comedies. Okay, so these are just queries that are enabled because I added that queryable attribute. And there's no query enabled by default. If you add the attribute, you get all these different semantics. But out of the box, if you have 2012.2 update, 2012 update 2, you'll get this support for top, skip, order by, and filter by applying the queryable attribute. Now, that's great, but we talked about query validation. I don't want to necessarily allow any and all types of queries. How can I change that? Well, we provide a bunch of helpers, a bunch of validation helpers that you can use. For example, I can say, allowed order by properties, for example. In this case, let's say I'm only going to allow you to order by genre now. You can't order by anything else. Okay, and let's see what happens. Let's execute the query. So we got the data. I'm going to F12 just so you can see what's happening on the wire. If I say order by equals genre, that worked, and I should see it order by genre. Yes, it is. So nothing in action, etc. Now, if I try and order by something else, like a rating, now I'm getting a 400 because the server is saying, I'm sorry, I don't allow that. And it still is returning a response. Like you notice I actually got a response. But it's not actually doing that particular ordering. And that might be important. Like maybe that particular sorting on that particular property is really expensive, like it's not indexed or something like that. So this is a way that you can scope down how much query you want to support. There's always, if I look at the queryable attribute, there's always a hook where you can, where's the validator? Yeah, this validate query method where you can plug in and do whatever validation logic you want. You don't just have to use our little property. Our properties are some helpers that we give you out of the box. But if you just want to write some code and say, give me the query, let me look at it. The query is encapsulated in this OData query options object. You can look through the abstract syntax tree that was parsed, and you can do some like pattern matching or whatever logic you want there to choose whether or not you accept or reject that query. Okay? So that's simple query and query validation. Let me show some new stuff. This is not shipped yet, but it is available in our nightly builds from the CodePlex project. Okay, this is a different sample. And this one is going to show some other query capabilities. Let's go to localhost 1, 2, 3, 4, 5. Data customers, right? Is that right? Okay, so in this case, this is a OData service that's representing an entity set with a list of customers, and the customers are pretty simple. You know, they have an ID and a name, but maybe I don't want all of the properties for each of the entities. Maybe I only need some of the data. Like I don't need the ID. Maybe all I need is the name in my particular case. These entities actually have very few properties, so the value proposition perhaps is not as compelling. But imagine you have an entity with like 30, 40 properties. Like if you go to like Facebook, for example, has a /me endpoint in their API, and it has all these properties for a given user in the system. And it's very convenient. You know, it's tons of stuff. So instead they give you a way, you can say, I only want these particular characteristics of the user. This is a similar idea. So let's say I want customers, but I want to select just the name. So select means I just want part of the data. These are the properties that I want. So you notice the IDs just disappear. They're no longer there in the payload. So I just trimmed down the payload, made processing of the data easier. I can also say a different operator, which is expand. Expand says that when I request this entity, I would like you to expand this particular navigation property. Don't give me a link. Give me the data in line, because I don't want to have to go back and get it. I'm going to need it anyway. I'd like to cut down on the number of round trips. So if I say expand orders, now I'm getting the customers and their orders directly in line. And you can chain down through. Like orders in this case actually has, this is a chain of relationships. Customers have orders, and orders have order items. I can expand those too directly in line in the repayload. And these things can be composed. Like I can say, well, I would like that, and I would also like to only select, though, the purchase date and the name in the response payload. And now you see it gets trimmed down to just a set of properties. So that's support for select and expand. That's not shipped in Visual Studio 2012 Update 2. This is something that we're working on right now, but it is something you can go out and play with in our nightly builds. And
can you just show the code that's doing that?
Sure. I will show you the code. There it is. Yeah. Oh yeah. Now, one of the things that changed in this with these updates, like before, you would only put queryable on a collection of stuff, but with select, you actually sometimes want to say, for an individual entity, I actually only want to get these properties for that individual entity. So you can also put queryable now on on a get for a particular, like this one this is the get for an ID. So you can query on individual stuff as well. I didn't actually show that, but you could do like a select name for an individual customer, and you would just get its name. What's that? Where's the data stored? It's stored in the database. Like these model types. I'm just using, I think this app is just using, EDM. Yeah, there's my EF data context. And so each of those queries, what's happening, let me go through again. Actually, let me go back to that, because I got a slide to answer this particular question. So here, let me tell you what's happening in these samples. There's that queryable attribute that's called an action filter in Web API, and it's doing all of these things for you automatically. It sees the URI on the request. What an action filter does is it sees the request before it hits the action method, and it also sees it after. and it sees the URI as the request comes in. It parses the query, and it's doing that using OData lib. OData lib has a OData query syntax parser in it that parses it into an abstract syntax tree. And you just get the nodes. And then we have a component, which we call the OData query options, which can then take that abstract syntax tree and convert it into a link expression. And that works great if you happen to have an iQueryable. In the process, it also validates the query to say, is this thing OK or not? And then it can apply the created link expression to your iQueryable if you so choose. The queryable attribute is doing all that stuff for you. It's parsing the query, turning it into a link expression, applying it to the iQueryable on the way out, and then you get your result. Now, when you apply the link expression to the iQueryable, if that iQueryable's query provider happens to be EF then does a whole bunch of work to take that link expression and figure out how to turn it into a SQL statement. And then it actually runs against the database. So this is going all the way down to the database. I may even be able to show that. Here, let me... can I do this fast? Let's go. So here, let me go back to this other sample with the paging. All right. Let me do dollar order by equals genre. Execute the query. Okay, we're ordered by genre. If I go back in here, I think there's this feature in IntelliTrace where I can break, and I can see the query that was actually executed. And you see down here that order by extend.genre. Okay, you see that? That's going all the way down there. If the SQL heads in here can probably read that better than I can, but I'm pretty sure that means that it's going all the way down to the database. Okay? Sorry. Yeah. You want to see how each of those things gets translated by EF? That's a wonderful exercise to do. I'm not going to do that right now because I got too much to show. But feel free to do exactly what I did. This sample that I just showed, that paging sample with the movies, it's a public sample. You can go get it right now. Go to asp.net/webapi and click on the Samples tab and look at the OData paging sample. And then you can click into IntelliTrace and look at the SQL queries and find out what EF is actually doing and send them nasty emails if you don't like their queries. Yes? We already do. We have an async entity set controller. If you want to use EF6, which has a built-in async support, that's awesome. We think async is awesome. In Web API, everything we do is async up and down the stack. So, of course, we provided an async entity set controller so you don't block your server threads and you use your resources more efficiently. OK, great. I'm moving on. OK, just want to make sure everyone realizes. Make sure you validate your OData queries, with great power, great responsibility. Use query validation. Don't just turn on the big red button, expose your whole world to queries, unless that's what you really wanted to do. It's great for demos. It's lots of fun to play with, but you probably do want to do some level of query validation. If you don't, you may have to deal with this guy, and so don't want to go there. Okay? All right. Moving on. Actions. Let's talk about actions. Actions are a concept in OData where you have it's basically a service operation. Now, sometimes you have, I talked about before, you have an entity that you can do actions on that entity. And depending on the state of the application, depending on the state of the entity, those actions may or may not be available. This is a very hypermedia-like concept where you can follow links in order to traverse the workflow of the application. Sometimes CRUD operations just isn't enough. Get, post, put, delete, create, read, update, delete. Sometimes those type of operations don't do enough for what you need, and you need a way to just write code, right? Like just do whatever you want. Like you're implementing complex transactions, doing multiple things at once. You want to have extra data that you need to package with the request. That's not not what you would normally send per the CRUD patterns. In any of these cases, you need a fallback way of dealing with that, and actions is a way that you can do that in OData. So what is an OData action specifically? They're operations exposed by your OData service. They can have side effects when they're invoked. They can return data, but you don't compose them. It's not like you can, in the query, in the URI, you can't say, here's this entity set, execute this action, and then also execute this action on top of that action. That's like I think you can do that with functions, but you can't do that with actions. They do show up in metadata. They show up in the $metadata document, and they can also show up at runtime in the payloads that you see, so that you can know, oh, I got this movie thing. Oh, and looks like, yes, there is a checkout action. They can be bound to an entity type, or actually not. Like you can just have actions that are sort of global that you can call, like create movie. I'll show that in a second. And they can be static on an entity, or they can be transient. So a static would be an action that you can always do in an entity. A transient one would be that sometimes it's there and sometimes it's not, depending on the state of things. Let me show you what that looks like really fast. All right, action sample. Okay. Here we go. So the convention for implementing actions, what you got to do if you actually want to support an action. Let's look at the movies controller here. This controller has a bunch of actions on it, and these actions are just methods. They just have method names, right? They're not following any of the other normal CRUD-based conventions. And then they take in the key, and they can optionally take in this OData actions parameter. That's the thing that's packaging up all of the parameters that were sent in order to execute the action. Honestly, this is a little clunky. Like ideally, you would actually have those things parsed out and handed to you, so you have each of the separate parameters already parsed. We'll get there. This was a V1, and that's as far as we got. But you at least have this component, this abstract notion of here are the parameters for this action call. Okay? Other than that, they're just normal methods, and you write code. Handle the action however you like. Now, you do need to add these actions to your model. Remember, when we did the convention-based model building, the only thing that we gave the convention-based model builder was the entity types. We didn't give it controllers, so it has no idea that these action methods exist. It just knows about your entity types. So you do need to manually add the actions to the model. So let me show you the code that's doing that. If we look in this web API config, which I think is where it is. All right, here's the get model method. This action, which is being added, is a transient action. Depending on the state of is checked out on the movie, it may or may not actually produce a link for this action. These other actions, like this one here is the return the movie action, is just a static one, so it just says hang this action off of this entity type. Same thing for this one, except this one also takes in a parameter. This one sets the due date for the movie. And then these are ones that operate on collections, because you can have an action that operates on a collection of entities. And then down here is an action that's not actually bound to anything. It's just, I want to add a new movie to the system. That can just sit off the root of your OData service. So if we run this, all right, we downloaded some movie data. Let's look at what the movie data looks like. And this movie data is going to have all sorts of interesting stuff in it, all sorts of interesting metadata. But if we look closely, like here is the movie Maximum Payback. Sounds like a great movie to watch. And it has these actions available in it. So container.checkout is one of the actions. Container.return is another action. And it's providing me the user-friendly description for the action and also the URI that I need to use to invoke that action. I can get more details about parameters for that action from the $metadata document. I'll show that in a second. All right, now if I check out this movie, that checkout request updated the movie, and actually I got the movie back. And you'll notice now this is again the Maximum Payback movie, but you'll notice there's no checkout action anymore. At least there shouldn't be. If you see it, yeah, I don't see it. So there's a return. Yeah, return, set due date, and that's it. Okay, so that's one of those transient actions. And you can create new movies, test. That's an action that's off of the base, and so forth. So that's an example of how you do, you can add arbitrary logic to your OData service. So if there's something you're finding in the service that you can't model using EDM, you always have this fallback to drop back to just what are essentially service operations. Okay. Great. Last thing I want to talk about is batching. So this is a pattern where you have multiple requests that you want to accomplish, but you don't want to have to go like, update, 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 update for like 10 different things. Instead, you just want to send one big request that has all those different changes in it so you get them all at once. In OData, that's accomplished using MIME multipart. All the different requests are packaged into a single request payload in different parts of a MIME multipart request. The order of the way those requests get processed in Web API, you have some control over. You can by default, they'll be processed sequentially, but you also have the ability to say, you know what, just process them in any order you like, and so they can basically be processed independently. And the nice thing about this pattern is that you can reduce bandwidth, you can reduce chattiness, you can reduce how much battery you're using on like if you're dealing with a mobile device. The mobile device can, instead of sending lots of requests, can just send one. And it's pretty easy to set up. So I'll show that to you really fast. Okay. Okay, so this application is basically the same one as I showed you at the beginning. It's managing to-do lists and to-do tasks. But instead of every single time I click something in the to-do list, updating, making a request to the server, instead I make a bunch of changes to the to-do list, and then I have a button that says, OK, now save them. And then I want to go and update all those to-do lists, all those to-dos in that particular to-do list. Now, let's go ahead and do one. So I'm going to F12 again so you can see what's happening on the wire. Start. I'm going to check this, uncheck this, take a cold shower. And then I'm capturing good, save changes. Cross my fingers. OK, so I sent a request to this special /OData $batch endpoint. And I got a 202 back. And you notice that the content type of the request is multipart mixed. If we look at the actual request body, you'll see all these separators in the request. And you'll see a whole bunch of put requests. Put, to do 8. There's the request payload. Here's another request, put, to-dos 14, and there's the request payload for that guy. All right? And they got sent up to the server, and the response says 204 for all of them, all good. Now, if I go to the server, let me do that again, actually, but let me set a breakpoint now on the to-dos controller on the update method to show exactly what's happening here. Whatever. Save changes. Okay, so I hit once, for that first to-do item. Which one's this one? This one's take a cold shower, and is done is now set to true again. If I F5, I'm going to continue to flow through. Boom, it gets hit again. This time with the second to-do item update, get a haircut, setting its is done to false. All right? So what's happening here is as that request comes into the Web API pipeline, we see that multipart MIME request payload. We know how to parse it, tear it apart into individual requests. And then we take each of those requests and push them up the Web API pipeline again. So they execute as if they were just independent requests. But when they came in on the wire, they were actually just one big request. And then all the responses get collected and sent back. Now, to enable that endpoint, I did have to do a little bit of code, but not much. In my Web API config, you notice make some space here, make this bigger for the people in the back who are straining their eyes. All right. Stop debugging so I can edit this. OK, here's my route for my OData service. And it looks like a standard route, the prefix and the model. But now there's a new parameter that we've added to this extension method, which takes a batching handler, a handler that you want to use to handle taking apart the different individual requests in the batched request and send them up the pipeline and deal with all the responses. And this default server, that's actually Web API. That's like its default server instance. And it needs that so it can take the requests and push them up the server instance again. So the whole pipeline will run. All the message handlers, all the filters, and so forth. You can implement your own handler if you don't like the way our batching handler actually works, and just plug it in here. This is a new feature. This is not in, again, the Visual Studio 2012 Update 2 release. This is a vNext feature that I'm showing you right now. But it's something you can play around with. It's in our nightly builds. We have So on the Coplex side, there's some spec content that you can read through on how to set this up. But that's how it works. So you just add a batching handler, and it'll add that endpoint for you, that $batch endpoint, so that you can have send batching requests. To send the request, I'll just quickly mention, if I go to my scripts, how did I actually create all that my multi-part gobbledygook? Well, OData plugs you into this wonderful ecosystem of clients and client frameworks and client code. So if we look at the save changes handler in this code, in this case, I actually did take another dependency. In addition to using jQuery for sending requests and Knockout for binding the data to the UI, I also pulled in data.js, which is a fairly low level but very useful JavaScript library for interacting with OData services. So that's where this OData request, that's where this OData.request method is coming from. And you'll see here's the batched requests, and inside the batch requests there are change requests, and so you can do things like both read and write within that batch. There is also a semantic in OData where you can have a change set, where you can have a set of requests in the batch where the first request does something, and then the second request is able to refer to something that the first request did, and they all sort of happen in the context of a transaction. We don't support the change set semantics yet, but we are thinking about it. We want to support it. We're working on it. This particular implementation just supports simple batch-based requests, where each of the requests are basically independent. Okay? So that is batching. All right. Good. So, use batching, save electrons. You don't have to use so many electrons on the wire. It's a very green and environmentally friendly thing to do. All right. I thought it'd be useful just to go over real fast what features are already out and supported, what features are coming soon that are in preview, and what features are still not done but are coming later. We support CRUD, we support link generation, query, server-side paging, Atom and JSON formats, link generation actions, model building, and so forth. That's all the stuff that you saw. The stuff that's coming soon, select and expand, are out, but they're not supported yet. They're in our preview builds. You can go play around with them. We have preview support for $value, preview support for $batch, which was the batching that you just saw. We also added some extensibility to our formatters that allow you to support things like name streams and media entities. Media entries, sorry. These are cases where you want to have images or media content in your feed, stuff that's not just JSON or XML. You can support those scenarios using our preview bits. It requires a little bit of code, but you can do it. In the future, not in this next release, but post this next release, we plan to be working on support for untyped, support for scenarios like containment, where you have entities that are really contained by another entity set instead of having to have everything be top level. We don't have support for functions yet. We're still working on that. Support for change sets, $count, and spatial types. Those are all things that are coming later. You can read about all the features that we're working on now on our Coplex site. We publish our specs publicly, so you don't have to come and ask me, what are you doing next? Well, we're trying to be as transparent and open about it as possible. You can see up to the minute what the dev has checked in for any of these features, and you can, of course, grab a nightly signed build. Now, the question I always get when I talk about ASP.NET Web API and OData is, well, that's great. That all sounds cool. I like it. But how do I think about this relative to WCF data services? Because we have this other framework at Microsoft that you also can use to build OData services, and it's great, and it does certain set of things. So this is my best effort to describe what the story is there. There are three key value props that I think Web API adds over WCF data services that are probably the main reasons why you would go with this model. It really makes it easier to support non-SQL-based data sources with a component-based model. You saw that the way you implemented support for entity sets is you had an entity set controller, you got the request, and then you did whatever you want. In my case, I had some code that was hitting EF, but you could do whatever you wanted there. You could go to nhibernate. You could go to call a Web API. You could do whatever. Implementing support for custom data sources in Web API is significantly easier than it would be to do with WCF data services. You can do it with WCF data services. It means implementing providers and such, but they're a bit hard to do. It's easier with Web API. With Web API, it's also easier to control your query space. You can validate and restrict the amount of query you support to just the set of things that you want. It's also easier to add, I would argue, lots of custom business logic. In WCF data services, the way it works is you have an interceptor pattern. As requests are flowing through the system, you get opportunities to intercept, inspect what's going on, and try and change things so that the runtime then does what you hope it would do. With Web API, the model is very different. You get the request, and you have the full context of the request. And then you also have full control over what the response is sent. It's up to you. We give you the components so that you can construct the right thing. But you can do whatever you want. If you want to fiddle around with headers, do something slightly different, you've got the whole HTTP response message that you can work with. So you have more control, more context for adding custom business logic. So this table, I'll go through it quickly. The architecture of WCF data services is much more interface-based. You have these providers. Web API is more about components. We're giving you pieces that you can use to build up your OData service. There's a little bit more flexibility in that model. WCF data services is server and client, and we actually continue to support and recommend the WCF data services client library. We do not plan to build a separate one for Web API. You can call an OData service using HTTP client, which is what we typically tell people to use when you're calling a Web API. You're just issuing HTTP requests. A lot of my code, it was just doing pure jQuery. It wasn't actually doing anything fancy with an OData library. But if you want to leverage some of the more involved OData features, having a library is helpful. And WCF Data Services Client for .NET is what we would recommend using. The maturity level for these frameworks is different. WCF Data Services continues to chug along. They're pushing out updates on NuGet. They're up to 5.5 now, I think, is the latest release. They continue to invest. Web API OData was a V1 release in the 2012 update 2, and we're working on our next release, so it's a little younger. The amount of feature completeness is less. Like there's obviously OData features that we still don't have yet. I think we've plugged a lot of the big holes in in the preview bits that we have out and that we'll be shipping shortly. But there are still some things that WCF Data Services can do that Web API still can't. If you'd like to help us fill those holes, feel free to talk to me, and you can submit some pull requests. The flexibility with WCF Data Services, I would argue, is where you might have some problems. It tends to be harder to compose certain things like you can do with Web API. With WCF Data Services, typically you want an iQueryable. It really was built to have an iQueryable underneath it. You can do things without an iQueryable, but then you're really going off and writing a whole lot of stuff. With Web API, it's much, much simpler. You get the OData query options, and then you map it to whatever query system you'd like. The support for business logic we talked about. It's easier to do with Web API because you have more context. Another interesting thing about Web API versus data services is an OData framework. It's built for OData. With Web API, yes, I'm exposing data using OData, but I also have the option of other formats as well. Like these things are just API controllers. If you want to also support just your own JSON format, your own XML format, or other interesting Web API formats, you have the flexibility to be able to do that, to add additional formats. But a ding for Web API, one of the key features we're missing is that we do require you to have typed data. In the future, we do plan to support untyped, though. We are working on that. All right. I'm sure people have questions about that. I'll stick around afterwards to answer them. So in summary, Web API OData gives you components for building OData services. OData is a great open protocol that helps you solve common Web API problems. You can use as much of it or as little as you like. You can try out the new Web API OData features today. They're on the ASP.NET Coplex project and in our nightly build. And go take your Web APIs to the next level with OData. And thank you very much for attending.